Here let's look at solving two absolute value inequalities. The key thing to look at when you're looking at solving an absolute value inequality that's going to determine our strategy is whether that you have an absolute value with a less than or an absolute value with a greater than. So isolate the absolute value first. In this case, both of our examples are already in that format, and then look at that symbol. That's going to help us as we go to rewrite. When you have an absolute value less than some number, we're going to write two inequalities and use the word and. Kind of a goofy way to remember that. Think of it as less than with the word and in there. And so we're going to write the statements 2x plus 5 is less than 3 and 2x plus 5 is greater than negative 3. I think of these as original and opposite. So the first inequality that you write when you're rewriting your absolute value inequalities looks a lot like the original problem, just without the absolute value bars. The second inequality is going to be the opposite. It's the opposite inequality symbol, a greater than, and it's the opposite of 3 with our negative 3. So think original and opposite. Then solve each of these for x. So subtracting 5, we have 2x is less than negative 2, and dividing by 2, we have x is less than negative 1. Same thing here, subtracting 5, 2x is greater than negative 8, and dividing by 2, x is greater than negative 4. So oftentimes it helps to picture this on a number line, so negative 4 and negative 1. So saying that x is less than negative 1, you can imagine that going to the left from negative 1, and saying that x is greater than 4, you can imagine that going to the right from 4. And so this and statement, you can see how the values are trapped in between negative 4 and positive 1. And that's going to be our solution. When we have this less than our and statement, we're going to end up with a solution that's in between these two values. And so our solution here is going to go from negative 4 to negative 1, parentheses, since we do not have the equals option in our original inequality statement. So when you have an absolute value with a less than statement, you're going to have two inequalities with an and in between. You're going to end up with the values in between two numerical endpoints. So write one original inequality, it looks just like the original problem, and one that's the opposite. So how is it different if we have a greater than? So when we see less than, we're going to think less than, the word and. When you see greater, think greater with the word or. So we're going to write the original, 3x minus 4 is greater than or equal to 2, or, and then our opposite, 3x minus 4 is less than or equal to negative 2. So one original, one opposite. We do that in both cases. The difference is that here we're going to have an or statement. We're going to have two separate areas of solution. So adding 4, we have 3x is greater than or equal to 6. So x is greater than or equal to 2. Here adding 4, we have 3x is less than or equal to 2. So x is less than or equal to 2/3. So picture these on a number line. 2/3 and 2. So x is greater than or equal to 2. It's going to go off to the right from 2, greater than 2. Less than or equal to 2/3. It's going to go to the left from 2/3. So notice how these are going in opposite directions, that we're saying x could be from the green region or the red region. It's an either or, whereas on the last one it was an and, that they overlapped each other. So in our solution to these, we're going to have two separate intervals. Our solution is going to go from negative infinity to 2/3 with a bracket here since we have the equal option, and then from 2 to infinity. So when you have a less than symbol, think about an and inequality statement. You're going to end up with one single solution because your x's satisfy both of them, the first one and the second one. When you have a greater than symbol in your absolute value inequality, you're going to end up with a solution that has two separate parts. The solution can be from the first part or the second part. So think about less than and greater as you're rewriting your absolute value inequalities.